In the last video, we talked about the math constant I, or the imaginary number. In this video, I want to talk about complex numbers. So complex numbers, well, first let's talk about just where they kind of fit in. So first, we have our whole numbers. It's like 1, 2, 3, blah, blah, blah. Okay, we can put that in a little circle. Then, including the whole numbers, what we have, if we want to expand our number set a little bit, we have integers. Integers are usually written as a Z, little double bar Z. It's in German. And they include negative numbers and 0, right? Okay. So those are integers. If we want to go out a little bit farther, we have rational numbers. Those are numbers that can be written as a ratio. Also, a repeating decimal would be a rational number because they can be written as a ratio. So this is like 1/3, and then we'll put, I don't know, 0.5 repeating. Okay. And then over here we have rational numbers, but then we have irrational numbers. And I'll put them in their separate little category because they don't include any of the numbers here. So over here we're going to have our irrational numbers. Oh, by the way, commonly rational numbers are written as a Q with a bar. And we have our irrational numbers, and they're like our math constants, and square roots of non-perfect squares, like square root of 2, and we'll have pi and e in there, okay? All of these numbers are real numbers. Real numbers is commonly denoted with a double bar R. These are real numbers. Okay. So we have our whole numbers, our integers, our rational numbers, and our irrational numbers, they're all real numbers. And there's something beyond that. There's something that encompasses them and also our imaginary math constants. So those are called complex numbers. So all of these numbers, irrational numbers, whole numbers, integers, and what we're about to go into now are complex numbers. Okay, so all of the numbers that you've ever known, they're actually complex numbers, written as a C with a bar. And I'll go through them now and why all of the numbers that you've known so far are complex numbers, plus some new stuff. Okay, but just so you know, everything that we'll be dealing with are complex numbers. Okay, so complex numbers, they take this form, a plus bi. Okay, in some books you'll see x plus yi. Doesn't matter. For this class, we're going to use a plus bi. I'll just erase it. A plus bi, where I is equal to the square root of -1, as you know. And A and B are real numbers. So they're elements of the real numbers. Okay? This little pitchfork E means elements of. So this means A and B are elements of the real numbers, which you can write sometimes as that double bar R. All it means is they're real numbers, okay? So an example of this would be, 1 is a real number plus 2, which is also a real number, times I. Another example is 3 plus pi I. Okay? Both real numbers. Now, numbers that you haven't seen are numbers that are purely imaginary. Okay, and that just means that their A is 0. So 0 plus 3i, we can just rewrite that as 3i. And that's a purely imaginary number, meaning its real component, the component that's just solely real, is 0. Okay, if we wanted a purely real number, we'll call them, then their imaginary component would be 0. And those are the numbers that you're used to. So if we had 5 plus 0i, well, that's just the number 5. But all these numbers can be written as complex numbers. But when we talk about the complex numbers, we're referring to every number, including numbers that have I in them. Okay, that have an I component, I should say, that where the B value isn't 0. Okay, so that's what a complex number is. It's really any number, but they might have an imaginary component. I should go as far as to say this is called the real component, and this is called the imaginary component of the complex number. Okay. So now I want to go through how to multiply these, how to add them, how to factor them, and things like that. Okay. So first, let's talk about addition. Addition of complex numbers. In this instance, you're pretty much going to treat I like it was x. Okay, it's not x, it's the square root of -1, but you're going to treat it as such. So say we had the complex number 3 plus 2i, and we wanted to add 4 plus 5i to it. Okay. You're just going to take you're going to combine like terms. You're going to take the real parts, add them together. So 3 plus 4 is 7. And then you're going to do a plus sign, and you're going to add your imaginary components together. So we have 2i plus 5i is 7i. Okay, so that's all we're going to do with addition. Subtraction is the same way. Say we were subtracting these. We'd get 3 plus 2i minus 4 plus 5i. And you just combine their components, just keeping in mind that we have a negative symbol here. So that's going to be 3 minus 4. So I'll erase these. 3 minus 4, which is -1, is the real component. And then we have 2i minus 5i. So it's going to be a -3i. And we could take the negative out. But we can leave it in for this case. Okay? So that's all we have to do for addition. Multiplication is very, very similar. However, when we are, let me write multiply. We just have to keep in mind that these I squared is -1 because you're going to end up squaring things when you are foiling. So let's multiply these two complex numbers together. So we have 3 plus 2i, and now we're going to times it by 4 plus 5i. Okay. So we have first, 3 times 4 is 12. Outside is going to be 15i. Inside is going to be 8i. And last is going to be, okay, so this is where it gets interesting. 5 times 2 is 10. And we have I times I, which is I squared. Okay. Well, I can combine like terms here. I have 12, and then I have 15 plus 8, which is 23. 3i. Okay, and then we have a 10 times I squared is negative 1. So we actually have 12 plus a negative 10. So that's going to be 2, the final answer, I'll write it on actually the next line. 2 plus 23i. Okay, now let's talk about division. So say we had, and really, division, I wouldn't exactly say it's division. You're just making something look like a complex number, okay? So there's sometimes it's beneficial to graph these things or to put them in a standardized way to maybe convert them into another way of looking at a complex number. So really, when we talk about things like dividing, like 3 plus, I think it was 3 plus 4 I had, divided by, that doesn't matter, 2 plus 3i, really, our goal is not to actually divide, it is to make it look like a plus bi. Right now we have an I on the top and the bottom. It does not look like our a plus bi form. We need to make it look like that. And how we're going to do that is we're going to multiply both the top and the bottom by the complex conjugate. Okay. And the complex conjugate is just the same. So we have 2 plus 3i. The complex conjugate of this is going to be 2 minus 3i. Okay, so what you're essentially doing is you're making it a difference of squares, which is going to drop out that middle I term. The last term is going to be an I squared, so that's going to be a real number, and you'll end up with all real numbers on the bottom. I'll show you. Okay, so we're going to multiply both the top and the bottom by the bottom's complex conjugate. All right. Well, let's take the bottom first, and we'll do 2 plus 3i times 2 minus 3i. So first is 4. Outside is negative 6i. Inside is positive 6i. So the imaginary component of the bottom drops out. Oops. Drops out I component. Because the last term here, negative 9i, I squared, well, I squared is negative 1, so this is actually going to be a positive 9. So it's going to be 4 plus 9, which is 13. So our denominator is actually 13. So in the bottom we have 13. What about on the top? We have 3 times 2 is 6, sorry. First, outside is negative 9i. Inside is plus 8i. And last is negative 12i squared. Okay, we can reduce this. We can, I squared, well that's negative 1, so we have negative 12 times negative 1, that's a positive 12. Positive 12 plus 6, well that's 18, so we're going to have 18 minus I over 13. Okay, and this is not exactly in our a plus bi notation yet. We have to put it that way by doing 18 over 13 minus 1 over 13i. Okay, that way my a is 18 over 13, my b is negative 1 over 13.